In question 5, we have a semicircle with center O, radius R, and diameter AB. The point P on a circumference is such that the area of the minor segment of AP is equal to half the area of the minor segment on BP. It means that this area is basically half the area of this given area. So the angle AOP is x radians. We have to show that x satisfies the equation x equals to 1/3 into pi plus sine x. Then the first step, we can just simply write what is given in the question, which is that the area of segment AP, so segment AP, that is equals to half the area of the segment BP. Now, first finding the area of the segment AP, we can first find the area of sector AOP and then subtract it from the area of triangle AOP. So for the area of segment AP, we'll first find the area of sector AOP and then subtract it from the triangle AOP. So the area of sector is given by the formula half r squared theta. So in this case, we have half into r squared and theta is x. And the area of triangle will be given by the formula half AB sine C. So this will become half, and the two lengths are r and r, so that will become r squared. And the angle is x, so this will become sine x. As half r squared is common, we can simplify it and write it as half r squared into x minus sine x. Now finding the area of segment BP, so we'll be finding it the same way as we did for the segment AP. So the area of segment BP, that will be is equals to the area of sector OBP. So we'll find the area of sector OBP minus the triangle OBP. Now in this case, as this angle is x, so this angle will become pi minus x, as the angle on a straight line is 180 degrees, or in radians it is pi. So this will become 1/2 r squared into pi minus x, and then we'll subtract it from the area of the triangle, so that will become half into r squared into sine of pi minus x. Now we know that sine of x and sine of 180 minus x is the same. So it means that sine of pi minus x will be the same as sine of x. So we can simplify it and write it as, we can take half r squared common and write it as pi minus x minus, and this will become sine of x. Now using the original formula that we made, that the area of segment AP is equals to half the area of the segment BP. So area of segment AP is half r squared into x minus sine of x, and that is equals to half of the area of segment BP, which is half r squared into pi minus x. This is r squared, pi minus x minus sine of x. So half r squared and half r squared will cancel out on both the sides. You can cross multiply this 2, so this will become 2x minus sine x is equals to pi minus x minus sine x. And simplifying, as we have to make x the subject, so bringing x on this side, this will become 3x, and then you multiply by 2, so this should have been a 2 sine x over here. So this will become 2x minus 2 sine x. Now taking the minus 2 sine x on the other side, so minus sine x plus 2 sine x will become positive sine x, so we'll get plus sine x over here. And finally making x the subject, so we'll get x is equals to, dividing 3 on the right hand side, we'll get 1/3 into pi plus sine of x. In part B, we have to verify the calculation that x lies between 1 and 1.5. Now, a simple way of doing this is we will first bring the right hand side on the left hand side. So we can first multiply 3 by x. This will become 3x is equals to pi plus sine x. And then bringing pi and sine x on the left hand side, we'll get 3x minus pi minus sine x equals to 0. Now to show that the root x lies between 1 and 1.5, we have to show a change of sign. So first substituting x equals to 1, we'll get 3 into 1, which is 3 minus pi minus sine of 1. And substituting this in the calculator. So when we substitute this in the calculator, we get the value as minus 0.983. And when we substitute x equals to 1.5 into the equation, so this will become 3 into 1.5, which is 4.5 minus pi minus sine of 1.5. And the answer will be 0.3609 or 0.361. As we have shown a change of sign from negative to positive, it means that x lies between 1 and 1.5. In part 3, we have to use an iterative formula based on the equation part 1 to find the value of x correct to 3 decimal places. We have to give the result of each iteration to 5 decimal place. Now, as we already have the formula, which is x equals to 1 upon 3 into pi plus sine of x. And we know that the root lies between 1 and 1.5. So we can start off by taking the middle value, which is 1.25. Now, substituting x in place of x, we'll substitute 1.25. So when we substitute 1.25, the first value we get is 1. So this will become x equals to 1.36352. And please make sure that when you are attempting this, you're writing your values to 5 decimal place in all the cases. So I'll just be using 3 or 4 decimal place just to explain. So in the next step, in place of x, now I'll substitute x equals to 1.36352. So this will become 1.36352 over here. And when we substitute this in the calculator, we'll get 1.37339. Now substituting x equals to 1.37339, we'll get 1 upon 3 into pi plus 1.37339, and we'll get 1.37412. And then substituting x equals to 1.37412, we'll get, so this will become 1 upon 3 into pi plus sine of 1.37412. We'll get 1.37410. And when we substitute 1.37410, we'll still get the same answer. So the final answer will be, as you have to give it to 3 decimal place, so the final answer will become 1.374.